In my last video, I explained how I see path to superintelligence, and this is just general ideas. So now I will continue because now I have a lot clearer idea. First of all, LLMs are surprisingly good at reasoning because they don't even have any architecture for that or for abstract planning, abstract thinking. So this tells me that our neural networks and backpropagation are very powerful mechanism, because even if LLMs don't have any explicit architecture, they just have this attention mechanism, and they can just have like attention and process things sequentially. They can still decompose and create some plans. So imagine if we add abstract reasoning and abstract planning and hierarchical planning to LLMs, or LLMs to model that has this abstract planning. If we combine them, how much better? I think then we could have AI that's super intelligent in a lot of areas compared to humans, or maybe even in all areas. So I think Jan LeCun is correct. I think he's focusing more, he sees correctly the problems with LLMs. And I also think OpenAI and DeepSeek, and they will build very useful LLMs. And I think LLMs will become super intelligent and very fast in some areas. But also I think Jan LeCun is raising correct problems, and we do need to add hierarchical planning and abstract thinking to our AI systems. So what is hierarchical planning? Let's say my first plan on highest level is I want to go to Berlin. Okay, the lower level would be, okay, I need to go to Berlin with airplane, or should I go with a bus? Okay, and then below that, okay, airplane costs this much money, this much time. So that's, you have a hierarchy, and you go from the highest abstract idea to very low level precise steps. LLMs can actually do this because they can break down components while they generate sentences. So they can actually do this. But I think LLMs just don't have built-in mechanisms for this. So we use reinforcement learning and we use prompt engineering to maybe even hack or kind of cheat to create this abstract thinking. But I think if we add specific components to the AI model specifically for this, it will be a lot better. And it will be able to maybe learn and reason and plan a lot better than humans. And this is important, especially if you are at the beginning of your career like me. We have blank canvas, so we don't need to do LLMs. We can look at the next thing. We are not stuck with LLMs. So for example, OpenAI is stuck with LLMs because of all of the investment and money, and people need return on investment, and they are digged in. But we are not. So your idea could still be LLMs, but then you want to maybe add some other modules to it. Or I think I'm trying to reimagine the whole system from scratch, and I can add LLMs on top. But I think I want to start completely from scratch and think about this. So they just released VJEPA 2. This is something that has abstract thinking. So let me first explain. There is abstract thinking and there is hierarchical planning. So hierarchical planning, I still don't know how to do it. I will read more. But abstract thinking, so if I told you to prepare some speech for tomorrow, you will think of general ideas. You will not think of every single word, every single eye movement, every single hand movement. You will not plan for tomorrow. So you will just plan for a general, a lot more compressed, a lot less information idea about what you want to speak. So we are training LLMs and we are wasting computation. When LLMs are thinking, they are predicting each token. But that's a lot of wasted computation because we don't actually plan for every single word, every single action movement we will make. We will just plan about the abstract idea. So that's why LLMs are hacking it and they're wasting a lot of resources, and that's not how thinking should be done. We should probably have a way to represent those tokens in like a whole sentence into a single idea. So there is a paper by Meta also, it's called Large Concept Models. I think they just take a sequence of tokens, a whole sentence, and sentence I think is a really good like you can represent idea in a sentence. So a sentence is a really good idea. So if you can represent a sentence, you can represent an abstract thought. And usually you should definitely be able to compress entire sentence of tokens into a lot smaller vector that will contain the abstract thought while disregarding all of the relevant tokens as which exactly word you use, which exact tokens, because it can be expressed, the thought can be expressed in many ways. So thought is a lot smaller piece of information that's easier to compute, to process, than the whole sentence that has exact tokens, which tokens it's using and words and stuff. And we just need the thought, we just need the core idea, we don't need the entire detailed sentence. So VJEPA 2 is released. I really like this. So this is actually creating those abstract thoughts. So they trained this on videos. It learned how the real world works a little bit. So it's a small model, just the beginning, but it worked. And then on top of its knowledge of how the real world works, they just added a bit of data and trained these robots to move arms. And they didn't even they didn't train the robot specifically for those actions. They actually just have a general world model that understands world generally and just need a tiny bit of data, or maybe even in some zero shot means no data. Just tell the, you see here, you see this image is the goal and this is the start. So JEPA is gonna generate this sequence of actions because it has the real world knowledge how to this needs to move. So this is, it's thinking in abstract space. So it's not even generating these pixels and videos. It's just thinking about with ideas. So how does it do that? So how does it think about ideas? We can use this in LLMs as well. Here. So how does JEPA think abstractly? Here, they have this video and they mask some parts of the frames. And they do it like in first frame, second frame. So they mask it throughout the whole video. And they have this original video. So the first step, but this is not what they do, but let me just explain the first step so you understand easier. Imagine you want to just predict which frames come here. And then you have these correct answers and then you calculate loss. Which blocks come here. So that would force the AI to learn about the physics, the motion, and it's also looking at the past frames as well. So it's learning about physics, motion rules. So it needs to know the general rules of everything. But you don't actually need to predict the exact pixels because it's not relevant. So we don't know exactly like which color this sky is here, there are some clouds. It's completely random. So that's unpredictable and it's wasted effort. So we just need to know that there is some sky behind, maybe some clouds behind, that they are randomly kind of dispersed. So just those kinds of information. And there is this shirt here, there is this part of the clothes and body. And so those are just the abstract thoughts that we need to know. We don't need to know like every color, like because it's unpredictable where are the clouds here. So we encode this image, scale it down. We have this encoder. So what this encoder will do is it will just scale down this image into a lot smaller representation space. So it just idea space, create idea out of it, or representation, embedding. And then we also do that for this one as well. We use, I think, they use the same encoder. So the AI is actually learning to predict from this part. So the scale down in the representation space. So the this idea to this idea, not this pixels to these pixels. And this is a lot smaller thing to do, a lot easier, a lot faster, a lot less computation. And it's a lot better because we are thinking in ideas, not in exact pixels, because I don't even know what pixels exactly are here. I just know that there is cloud here and there is this body here and that he's jumping, he's gonna go up, down. So that's the only thing I know, and we want to teach that to the LLM. So this is this high abstract thinking in the representation space. So we should do that with LLMs as well. We shouldn't think in tokens because it doesn't matter which tokens we use because we can express same idea in many different ways. So it's just wasted computation, wasted details. I also think that brain is too complicated and we don't need to replicate brain. I think backpropagation could be actually better. It's very simple and we understand it. And LLMs work surprisingly well. They have surprising amount of reasoning and thinking without even having the architecture specific for that. So that's crazy. It shows the power of our backpropagation and neural networks in real network, the computer neural networks. You can check this paper, A Path Towards Autonomous Machine Intelligence. It's good because it explains all of these beginning ideas. It creates at least something that we have, that we understand how humans think, how machines should think, this abstract reasoning thoughts, hierarchy and stuff. And then you can just Google for JAPA 2 and check the paper. It's actually good as well. So that was it for this video. Thank you for watching and see you next time.